Okay, hello students, and welcome to today's Friday Happy Math Hour. Today we're going to cover the exam 3 review for Math 2412. Okay, I think I have about 22 questions that I'm going to solve. Okay, question number 1. This comes from chapter 9.1. It says find the nth term of a sequence. Write an expression for the apparent nth term an for each sequence. Okay, let me do A part first. I guess when you try to find the nth term of a sequence, you first try to recognize a pattern. So for example, here we know that the difference between 1 and 3 is going to be 2. In the same fashion, from 3 to 5 is going to be 2, and from 5 to 7 is going to be 2. So the sequence is going to have something like an equals to 2n, because the difference is 2. Okay, so let's try that first. Okay, now once you have found a sequence, we have to test it if it's true. Okay, so 1 is considered my first term, 3 is considered my second term, and 5 my fourth term, and so forth. And 5 will be my third term, and 7 will be my fourth term, and so on. Okay, so let's plug in 1 to see if the first term is in there. If we plug in 1 for the n it's going to give us 2, which means that nth term formula is not the 1. Okay, but we know that there has to be something with 2n because the difference is 2. Okay, now if we have 2 and we need 1 for the first term, right? How about if we subtract 1 from the formula? Now let's see if that one works. Again, we'll start with A1. If we notice, if we plug in A1, it's going to give us 2 minus 1. It's going to give us 1. So that one works. But let's try it, say for the fourth term. Okay, I'm going to find the fourth term, see if it's true. So the fourth term will be 2 times 4 minus 1, which will give us 8 minus 1, which will give us 7. So since these two are true, that means this is my nth term formula that we're looking for. So that's my answer. Okay. Now let's try B. If we notice, on B, you have a positive, negative, and the sequence goes on in the same pattern. Forever and ever. Okay, so let's see how we can, how we can note a positive and a negative and so forth. So if terms have alternating signs, there's two things that might happen. If the first term is negative, then it's going to be parentheses -1 to the nth power. And if the first term is positive, it's going to be -1 to the power of n plus 1. Okay, if we notice, here we start with a positive, so it's going to be the second formula here on the right. So it's going to be an equals to -1, n plus 1. So that will cover the changing signs from positive to negative and so forth, right? So this has to be in the formula. Now, ignoring the alternating signs, because I already got the answer here for the alternating signs. Let's see if I can find a pattern from term 1 to term 2 and so forth. Here, guys, the difference, without the negative, is going to be 3. From 5 to 10, it's going to be 5. From 10 to 17, it's going to be 7. Now we can see a pattern right now. If we do it again, it's going to give us 2. And from 5 to 7, it's going to give us 2. That means since we went for 2 levels, right? This was the first stage, second stage. We know it's going to be n squared. Okay, that's a rule. If it's quadratic, we require 2 stages, right? So to get to the second stage, it's going to be something like n squared. And like before, we have to test if the first term is in there. My first term is 2. Okay, so let's plug in 1, right? Because it's my first term to the formula. It's going to give us 1, right? If we notice, that's not the formula because the first term, according to the formula that we found, is 1. But according to a sequence, it's 2. So that's not the formula. Okay, now, how can we go from 1 to 2? Can we just add 1? Sure we can. So we're going to add 1 to the formula. Let's see if it comes out. Again, let's try A1. It means I'm going to plug in 1 for the n's. So 1 squared is 1. 1 plus 1 is 2, which means it's there. Now, let's find the fourth term, right? Again, it has to give us 17. But I know it's negative here, but with the positive and negative, guys, I already got the answer here on the right. It's going to be -1 n plus 1, right? So that takes care of the changing signs. So it's going to give us 17. So I know this is my formula, guys. right? That goes first because that one goes from positive to negative, and the n squared plus 1 will give us the 2, the 5, the 10, and the 17. So this is my n-sense formula. Okay. Again, let me recap this problem here because this is very important. For some of the problems in the homework, if you go one stage, it's going to be linear, and whatever the difference is, that's going to be like my slope. Okay, it's going to be like like before it was 2n, right? If it goes 2 stages, it's going to be squared, something with a second power. If it went another stage, a third stage is going to be cube and so forth. Okay, that's a good strategy to use when you're trying to find the n-sense formula. Okay, now here, find the nth term of the sequence. This is still from section 9.1. Okay, here it says, so assume n begins with 1. Okay, because at times n can begin with 0 in some cases, but here, guys, assume n begins with 1. So we know it's going to be something, right? It goes from negative, positive, negative, positive. So for the exponent, we have to get the signs first. Okay, and here it is from before. Since the first sign is negative on the exponent, we're going to use, the first one, which is negative 1 to the n power as part of the exponent. Okay. Now we know it's going to be 2 to the n power because every base here is 2, right? 2, 2, 2, 2. If we notice, we won't, ignoring the negative and the positive, we go from 1 to 2 to 3 to 4. That means it's going to be just 2n, right? And then with a negative 1 to the n, it's going to take care of the negative, positive on the exponent. So this is my solution. But we can even plug it in to make sure it's right. So if we plug in, right, for the first one, we plug in 1 where the n is, when both n's are, it's going to give us 2 to a negative 1. Now let's try 2. We plug in 2, right, where the n is in the formula, it's going to give us 2 squared, positive 2 to the positive second power. If we plug in 3, right, for the third term, it's going to be a 3. We're going to plug in 3 for the enders, right, where the ends are. So it's going to give us 2 to a negative 3. And we plug in 4, it's going to give us 2 to the positive 4. Okay, so I know this is my formula, guys. Okay. I remember when I was taking this class back in the early 2006, 2005, I had a hard time with these. But the more research that I did, it's not that hard, right? If you have the right notes and the right tools. Now this is still from section 9.1. And again, guys, I'm trying to make the exam how most instructors will give. Maybe not every instructor will give all these problems here. For example, I only give about 10 to 12 problems, and I think here I went about, I'm going to go like 22 problems. But I'm trying to get, more likely the most important information that the instructors will probably give on this exam. This is called the recursively sequence. Okay. Okay, now we're going to use this formula here, guys. Okay, for recursively sequence, they have to give you at least 1 or 2 terms. Here they give us that A0 is equal to 1, and A1 is equal to 2. Here, guys, I color-coded them, okay, on purpose because we as students, when I was a student, we're more visual learners. So with a color code, for every A naught or A0, I'm going to plug in 1. For every A1, I'm going to plug in 2, right, which is in different colors. Now here's my formula here, guys. Okay, it's going to be AK equals to AK minus 2 plus 1/2 AK minus 1. I know this might look like a little bit intimidating, guys, but hopefully, the way I explained it, maybe it can make more sense to you. Okay. Well, here's the formula. Okay, so for every K, I'm going to plug in 2, right? Because this is my first term, my second term. Now comes my third term. My third term will be A2. So I'm going to plug in 2 for the K's, all right? So A to the 2 minus 2 is going to give us A to the 0. And A to the 2 minus 1 is going to give A to the 1. If you notice, A to the 0 is going to be 1, and A1 is going to give us 2, right? And the A0, which is the first term, is in green. That one is like in pink, okay? So I'm going to plug in, for A0, I'm going to plug in 1. And for A1, I'm going to plug in 2. Now let's evaluate. It's going to be 1 plus 1 because 1/2 times 2 will give us 1. So A2 is going to give us 2. And I put it like in brown. Okay. Now let's continue with A3. So A3, guys, I'm going to go again back to the formula. So it's going to be 3 minus 2, A to the 3 minus 2 term plus 1/2 A to the 3 minus 1 term. If we notice 3 minus 2 is going to give us A1. And A3 minus 1 is going to give us A2. So A1, I'm going to plug in 2, right? Because A1's in pink, right? I'm going to plug in 2. And for A2, right, it's in brown, I'm going to plug in 2. It will be 2 plus 1/2 times 2 will give us 2 plus 1 is 3. Now this one, I'm going to put it like in blue. Okay, so A3 will be blue. If we notice, they want to do the first 5 terms. So we already got the first one, the second one, the third term, the third one, and the fourth one. Now we need the last term, right? So I'm going to do A4. So again, A4, I'm going to plug in 4 for the K-zar. So it's going to 4 minus 2 is going to give us 2. A2. Yes. Does anybody have a question? Okay, let me continue. And A to the 4 minus 1 is going to give us 3. Right? A2 is in brown, is going to be 2. So I'm going to plug in 2 for A2. And A3 is in blue, so I'm going to plug in 3 for A3. This will give us 2 plus 1/2 times 2 will give us 2 plus 3/2 will give us 7/2. So these are my first 5 terms. 1, 2, 2, 3, and 7/2. Okay, now this is from 9.2. Okay? We're trying to find the nth term of an arithmetic sequence. Hey guys, this is a formula that we use for the nth term formula for the arithmetic sequence, which means we need to find A1 and D, which is the difference. Once you find those 2 components, you can come up with a formula. Here, number 4, guys, and on this review, this is straightforward, right? Because they give you everything. You see the common difference is 3, so they give us D, and A1 is 2, right? So they give us everything that we need. So all we do is plug them into the nth term formula. A1 is 2, and the difference is 3. We're going to plug them in there. Just simple algebra. So we get AN is equal to 3n minus 1. So this is my nth term formula. On an exam, I usually don't give this one, guys, because this is too easy for them, for the students. But I did it here as an example to what's to come. Okay. The most important thing, once you find your A1, which is the first term, and the difference, we can come up with a formula. Okay, let's do this one here. Okay. It says, write the term of the sequence, arithmetic sequence, whose 4th term is 20 and 13th term is 65. Write the first 11 terms of the sequence. Okay, this is a little bit more challenging, guys, because they don't give us a difference, nor they give us the first term. Okay, but let's see how we can do it. Hey, guys, there's 2 ways to do this one. Okay, the long way is more visual, but I recommend for you not to use that, because if they give us like the 30th term, it'll be too much work to do. So I want to show you the visual way so you guys can see what's taking place. And then I'm going to show you the way it should be done. Okay. This is a more visual way. Okay, so A4 is 20 and A13 is 65. So I'm going to write all the terms. This is my first term, my second term, my third, my fourth, my fifth, my 6th, my 7th, my 8th, my 9th, my 10th, 11th, 12th, and 13. We stop there, right? It's saying that A4 is 20, so A20 is going to be 1, 2, is going to be about here. And the 13th term will be here, will be 65. Okay? So how much is it from 20? How many? I mean, this is the 4th term, right? The 4th term, this is my 13th term. So how many terms is it? It's going to be 9 terms. Right, because from the 4th term to the 13th term is going to be 9. Okay, now how much is it from 20 to 65, right? The difference is going to be 45. So we divide 45 by 9 to give us the difference. The difference is going to be 5. Okay, now to get the first term, right, we divide 20 divided by 4, because from the 1st term to the 4th term, it's going to be 5. I mean, it's going to be 4, right? So 20 divided by 4 gives us 5. So I found my first term, which is required for the formula, and I found my difference. Okay, so with that, then I can plug into the formula. But let me do it the way it should be done. Okay, check this out. We're going to put A13 first, because you always put the highest term first. Then you're going to subtract minus the lowest term. So what's A13 minus A4? It's going to be 9, right? Or is it 9? So it's 9 terms. What's 65 minus 20? It's going to give us 45. Here's where you find the difference. 45 divided by 9 is going to give us 5. So that's my difference. Now, to find the first term, we're going to use one of these 2 here, guys, okay? I mean, one of these 2 terms here. I believe I can use the fourth term because it's smaller numbers. So A4 is 20. Means when n is 4, right? I'm going to plug in 4 for the n and 20 for A4. I'm going to plug in 20 for A4. Now, we solve for A1. 4 minus 1 is 3, right? 3 times 5 is 15. So 20 equals to A1 plus 15. We subtract 15 from both sides, so A1 is equal to 5, right? So I found my A1, my first term, and my difference. Now what we do is plug them into the formula. My A1 is 5, my first term, and my difference is 5. Now I'm going to distribute. 5 times n is 5n, and 5 times negative 1 is negative 5. Now we add them. So it's going to give us an equals to 5n. So this is my nth terms formula. Now to find A1, right? A1 is already 5. Now to find A2, we plug in 2 for the nth term formula. 5 times 2 is 10. If you notice the pattern, we're counting by 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, right? But they only wanted the first 11 terms. That's why I took out the 12th term and the 13th term, because they only want the first 11 terms. So this is my answer, guys. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Those are my first 11 terms. Okay. Okay, now here, guys, we're trying to find the sum of the 150th partial sum of the arithmetic sequence. Okay, there's going to be a formula for that. For the formula, we need to find the 150th term, because this is a formula, guys, that we need. We need A1, right? And the difference. What's the difference? It's going to be 5, it's going to be 11, right? And from 16 to 27 is going to be 11. I know the difference will be 11. So what we do is we have A1 and we have the difference, so we can come up with a formula. Okay, let's plug in the values for A1 and for the difference. And now we distribute. We're going to get AN equals to 5 plus 11n minus 11. So AN is equal to 11n minus 6. So this is my nth term formula. Okay, now we have to find the 100. Right? All we do is plug in 150, so it's going to give us a 1644. That's my 150th term. But we're looking for the sum, which means we're looking for the sum like 5 plus 16 plus 27 all the way to the 150th term. Okay? There's a formula for that one. For the formula, we need the first term and the last term. You see, there's my formula, which means I need my first term and the last term. So it's going to be S of 150, which means the sum of the first 150 terms is going to be n divided by 2, which will be 50 divided by 2, and 5, which is my first term, and 1,644, which is my last term, which is the 150th term. Right? We add them, so this will give us 1649 times 75. So this is my answer, guys. It will be 123,675. All that means that if we add all the terms from 5 to 150 to the 150th term, it's going to give us 123,675. Okay. Okay. Now this comes from I believe from 9.3, which is a geometric sequence. Okay. It says find the 15th term of the geometric sequence whose first term is 20 and whose common difference is 1.05. So for the nth term formula of the geometric sequence, we need to find my A1, which is the first term, and the ratio. Okay. So here's my formula. Right. There's a formula for the nth term of a geometric sequence. So I'm going to plug in the 20 for A1. I'm going to plug in 1.05 for the ratio. Okay. Since we're looking for the 50th term, we're going to plug in 15 where the n is. It's going to give us 20 times 1.05 to the 14th power. All we do is use a calculator. It's going to give us 39.59363199. Say round it off to two places, it's going to give us 39.60. Approximately, that's my result. Okay, now, here they don't give us the ratio, but they give us the first term, right? Recall from the previous formula that we need to find the first term and the ratio, okay? So my A1 is 5, and we're looking for the ratio R. Okay, so let's divide, right? For the arithmetic sequence, it's subtraction. For the geometric sequence, it's division. So we divide 45 divided by 15 is going to give us 3. And then 15 divided by 5 is going to give us 3. So we know that the ratio is going to be 3. A1 is 5, and the ratio is 3. Now, let's plug into that, right? We need to find A12, so let's plug into the formula. Right, so A12 is equal to 5 times 3, right? To the power of 12 minus 1. Which will give us 5 times 3, 3 to the power of 11. We use a calculator. It's going to give us 885,735. Okay, that's how we solve this type of problem. Now, problem number 9 is going to be similar to the one that we did for the arithmetic sequence, right? That they don't give us the first term, right? No, they give us a ratio. Okay, but I'm not going to do it the long way, like the visual way. I'm going to use the technique that we used. To find the formula, which was the second method that I used when I did the arithmetic sequence. Okay, again, right? But for the ratio means division. I need to find R and A1. So A4, right? A4 is 125. That's my fourth term. And my 10th term is 125 divided by 64. Okay. I'm looking for A14, which is a 14th term. Okay, now right here's our formula. A1 is A1, right? So this is more or less the formula that we're going to be using. Right? So A10, right, according to the formula, it's always, if you notice here, the fourth term is always going to be 3 for the ratio to the third power is always 1 less. So A10 is equal to 125 over 64. Right? We're going to divide it. A4 is A4, right? It's going to be 3, right? Because 4 minus 1 is 3, but this is a formula that we use. So the A1s cancel. So what's R to the 9th divided by R to the third power, right? Recall when we have the same base, like R and R, we subtract the exponents, the top minus the bottom, so it'll be 9 minus 3 equals to 125 over 64 divided by 125. Or 9 minus 3 is going to give us 6. If we divide 125 over 64 divided by 125, it's going to give us 1 over 64. Okay. Now we take the fixed root of both sides, right? The fixed roots. So R equals to 164 to the power of 1 over 6, which will give us 1/2. So I found my ratio, right? My ratio is 1/2. Now I'm going to use either the fourth term or the 10th term to find my A1. I'm going to use the fourth term. Right? A4 is equal to A1 times my R is 1/2, my ratio, times 4 minus 1. A4 is 125. So I'm going to plug in 125 for A4, which is the fourth term. And it's going to give us a 125 equals to A1, 1/2 to the third power, because 4 minus 1 is 3. Now here, guys, right? 1/2 to the third power is going to give us 1/8. Now to solve for A1, we multiply both sides by 8. Right? So 8 times 1/8, the 1/8 cancels. 8 times 125 is going to give us 1,000. So A1 is 1,000. Right? So I found my A1 and also my ratio. Now we're looking for the 14th term, right? So for the 14th term, I'm going to plug in 14 where the n is right for my 14th term, and also 14 minus 1 will give us 13. So it's going to be 1,000, right, times 1/2 to the 13th power will give us 125 over 1024. This is my 14th term. Okay. Again, this type of problem, guys, is more thinking like outside the, okay, and this is how I tell my students that going from pre-cal to a pre-cal 2 is very different. It's like from day to night. Pre-cal 2 requires more thinking, pre-cal 1 requires thinking, but not as much. It's mostly like formulas and stuff. But for Math 2412, it's like from day to night, from pre-cal to pre-cal 2. Number 10, it's in here, find the sum, right, of the geometric sequence. It says that I1 is equal to 1, and 12 is a finite number that we're looking for. So for that, we need a 1, and we need my ratio. Well, n is going to be 12, right? Because it goes all the way to 12. So my A1 is 4. My ratio is 0.3. And my n, oh, hey guys, this is supposed to be 12, guys. My bad. I put a 1 there. I'm sorry about that. Okay, I should correct that. A1 is 12. Okay, I'll fix that. So again, n is 12, right? So then A12 is equal to 4. A1 is 4. And my ratio is 0.3 to the power of 12 minus 1 minus 0.3. So you can the calculator, guys, and you get your answer. It's going to be something like, let me go back. It's going to be approximately 5.714. That's your answer. Okay. Let's move on to number 11. Now, number 11 comes from section 9.4. This is the principle of mathematical induction. Hey students, this method, when I was taking courses at the college, I remember that I had a hard time trying to understand the mathematical induction. Okay, I remember trying to follow the examples, and then I would ask the instructor or the tutors, is it correct? And they would tell me, yeah, it's already proven. But I didn't really understood what was taking place until I got to UTEP when we were doing some mathematical induction. I think it was for my senior year, okay, as a math teacher. I went for math, and I fully understood it. So the way I'm going to explain it the way I learned it, where I truly understood it, and it's not that complicated, guys. Okay, here we go. So first of all, guys, we need to show 3 things. We need to show that it's true for n equals 1. Then here, guys, all we're doing is assume value for sk, which means I'm going to plug in k for every n. And to be, guys, show true for sk plus 1. Here's the step that gave me a hard time when I was taking this course. Okay, show true for sk plus 1, which means that you have to prove that the next term is also there, right, for the formula to be valid. Okay. For example, it says here, use mathematical induction to prove the formula. Okay. And I say Sn is equal to 1 plus 3 plus 5 plus 7 plus ... plus 2n minus 1 equals to n squared. Because this means that this is the nth formula, right? Because the first term is 1, so if I plug in 1 here, it's going to be 2 minus 1 and will give us 1. For the second term, if I plug here 2 for the n, because it's my second term, it's going to give us 3. So this formula, guys, this is my nth formula here, which is equal to n squared. So how can we prove that? Okay, by following those 3 steps that I mentioned in the previous slide, which are going to be right here. Okay, so my first step, I have to show true for n equals 1. Okay, so I'm going to take the left side, right, which is 2n minus 1 equals to the right side. So if I plug in 1 on the left side, right, it's going to give us 2 times 1 minus 1, it's going to give us 1. If I plug in 1 on the right side, 1 squared will give us 1. You notice these are equal to each other. Okay, guys, but don't assume that it has to equal to 1. No, they just have to equal to each other. This might be a 3. If 3 equals 3, 4 equals 4, they have to be equal to each other. That means that I can proceed to the second step. Okay, which I'm going to go to the next slide. Okay, now, let me go back real quick. And also, guys, this is the way they wanted for you to prove it at a university. Because, here at the bottom, you have a line with two dots across it. That means that first step is done. Okay? Now, I have to assume true for sk plus 1, for sk. All I do in this step is just plug in k for every n. See, I plug in there for n and also there for n. You see, guys, that means that I'm done with step 2. Now comes step 3. Okay, here's what we're doing. Here's what we're going to prove here, guys. We're going to prove that my next term after this one is also there. So k plus 1 means that it's going to be the next term that we're trying to prove. Okay? So we're going to plug in k plus 1 for every k. You see I plugged it in there. And right, this is what's here, guys, but we're going to add in, I'm adding the next term. That's why I'm going to put k plus 1 where the k is right there, right? I'm going to plug in k plus 1 here where the k is. 2k minus 1, I'm going to plug in k plus 1. Has to equal to k plus 1 squared right on the right side. Now, you only work on the left side. You don't do nothing on the right side. Leave it how it is. Need to prove that the next term is also there, right? This is my next term. Okay, now. So if you notice, what's 1 plus 3 plus 5 plus 7 plus plus 2k minus 1 is going to be k squared. Right? So we have k squared plus, right now here we distribute 2 times k is 2k, and 2 times 1 is 2 minus 1. So this is the sk, and now we're adding the next term, which is 2k plus 2 minus 1, which will give us k squared plus 2k plus 1. Now this answer, guys, has to equal to the right side. So again, you don't work with the right side no more. You only work on the left side. So here, guys, if we factor this one and we factor it, it's going to give us k plus 1 times k plus 1. If you notice, this is k plus 1 squared. If you notice, they match. That means it's proven. Okay. Okay, now let me do one more example. Let me do number 12. Here again, we have 2 plus 4 plus 6 plus 8 plus plus 2n equals to n times n plus 1. Okay. Here we go. Again, the same 3 steps that we're going to do. So first I have to show true for n equals 1. So my left side is 2n, and my right side is n times n plus 1. So I'm going to plug in 1. So if we plug in 1, it's going to give us 2 times 1 will give us 2. On the right side, if we plug in 1 for n, it's going to give us 1 times parentheses and 1 plus 1, which will give us 1 times 2 will give us 2. You see, guys, they're equal to each other. That means I can go to step 2. So for step 2, all we're doing is plugging in as replacing n with k. So it's going to be 2 plus 4 plus 6 plus 8 plus plus 2k equals to k times k plus 1. Again, I just replace k for n. Now, okay, now one more thing that I want to say, guys. You have to write everything down. At times, students begin to get lazy and they don't write all the steps, right? If you don't put how it is here, guys, it's wrong. Okay, you have to show everything. Everything. Okay, I mean, for it to be proven. Now I'm going to plug in, I'm going to write this very same thing on the bottom for k plus 1, and then on the next term, I'm going to add k plus 1 for every k. You see, this is the 2 plus 4 plus 6 plus 8 plus 2k is here. Now I'm adding the next term, which means I'm going to add k plus 1 where the k is. But when you do on the left side, you also do on the right side. So I'm going to plug in k plus 1 where the k is right there. I'm going to plug in k plus 1 where the in parentheses k plus 1 is, so I'm going to plug in k plus 1 there. So on the right side, right on the right side becomes k plus 1 times k plus 2. Now comes, okay, on the left side, I got to show that the left side is equal to k plus 1, k plus 2. Again, I'm not going to work on the right side no more. I only work on the left side. Okay, now if you notice, 2 plus 4 plus 6 plus 8 plus plus 2k is equal to k times k plus 1, right? So I'm going to plug in k plus 1 for 2 plus 4 plus 6 plus 8 plus plus 2k. And then plus 2k plus 1. Okay, now guys, on the left side, what do they have in common? Right? They have in common a k plus 1, so I'm going to factor it out. If you factor it out, what's left? K plus 2. You see, guys, it matches the right side. That's how you prove it. Okay? Now comes number 13. Number 13 is section 9.5, which is binomial expansion. Okay, now, hey guys, this is a formula that I'll be using. I think the book uses another formula, guys, but I think this is more student friendly. Okay? If you notice, what's the deal with the red? Right? If you notice, hey guys, this is N, this is R. You see this one always matches for example, here, guys, the b would always match the exponent, here at the bottom, right? So, for example, n0 is equal to b to the 0, n1 is equal to b to the first power, and n2 is equal to b squared. So this is crucial, guys, when you're finding a particular term. Okay, it's going to make more sense as I go along with it. Okay, now, guys, for example, x plus 1 to the 0 power is going to give us 1. X plus 2 to the first power will be x plus 2, because this leads to the Pascal's triangle. Okay, let me show you what it means, right? So A4, right? So this is what we're looking for, the power of 4. If we notice, guys, right, it's going to be 1, 4, 6, 4, and 1. That means that this here, guys, means 4 combination 0 will give us 1. 4 combination 1 will give us 4. 4 combination 2 will give us 6. And 4 combination 3 will give us 4. And 4 combination 4 will give us 1. Because at times, guys, the book wants you to use the Pascal's triangle. But that's if you can construct it real quick, right, on your paper for the exam. But what happens if you have to the 15th power? That means that they have to go all the way to 15 rows. And it follows a particular pattern. For example, how do we use Pascal's triangle, guys? It's like this, right? We start with 1. And then we put 1s, diagonally. And then we do 1s. You see all 1s are here. And then we do, how do we get this from here? We put 1 in, 1 plus 1 is 2. And this 1 comes down. Again, this one comes down. What's 1 plus 2? 1 plus 2 is 3. 2 plus 1 is 3. And this 1 comes down. This 1 comes down. What's 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and so forth, guys. That's how we use Pascal's triangle. But not every time, right, I'm going to be able to use it. Hey, guys, 4 0 means 4 combination 0. Okay, and that's like, permutations. So here, guys, right, so it's going to give us 1. 2 to the 0 power is 1. 4 combination 1 is 4. 2 to the first power is 2. 4 combination 2 is 6. 2 squared is 4. 4 combination 3 is 4. 2 cubed is 8. And 4 combination 4 is 1. X to the 0 is 1. And 2 to the fourth power is 16. Now we multiply 1 times x to the fourth times 1 will give us x to the fourth. 4 times 2 is 8. 8 times x cubed will give us 8x cubed. 6 times 4 is 24. 24 times x squared will give us 24x squared. 4 times 8 is 32. 32 times x will give us 32x. And 1 times 16 will give us 16. Okay. Now, again here, if you want to use Pascal's triangle, right, you're going to get 1, 5, 10, 10, 5, and 1. Back to show you how we got the first one, right? How we got those. Let me go back here. Let me go back here. Previous. You see, guys, this is the fifth, right? You see, it's going to be 1, 5, 10, 10, 5, and 1. That's what I'm talking about. Okay. So, guys, so according to the formula, this is 5 combination 0, which is going to be 1. You see, it's color-coded, so you know what, if you want to use Pascal's triangle, or the formula, guys, you see, they match each other. You see, the 10 goes there, the 5 is purple, so it's purple there, and the 1 is red, it's red there. And then, right, so 5 combination 0 is going to give us 1, and 5 combination 1 is going to give us 5. 5 combination 2 is going to give us 10. Combination 3 is going to give us 10. 5 combination 4 will give us 5. And 5 combination 5 will give us 1. You see, it's Pascal's triangle. Now, I will just multiply them out. 1 times 32 to the x fifth, to the fifth power will give us 32x to the fifth power. And we multiply 5 times 16 times negative 1 is going to give us negative 80x to the fourth y. 10 times 8, right, will give us 80x cubed y squared. 10 times 4 times negative 1 will give us negative 40x squared y cubed. 5 times 2 will give us 10. It'll be 10x y to the fourth power. And 1 times negative y to the fifth will give us negative y to the fifth. Hey, guys, check this out, guys. Okay, look at the pattern here. If you notice, the exponent for the x, right? I mean, here for the x, it starts at 5. And then, right, this is the same thing as y to the 0 power. What should I go up here? Right? So how I'm supposed to do it, guys, just write the term 2x and y, right, times negative y. You see, it's all for every term. 2x, negative y, 2x, negative y, 2x, negative y. And then here, guys, for the combination, we start with 5, 0, and then 5, 1, 5, 2, 5, 3, 5, 4, and you stop where you go 5, 5, or n to the n. Now, look at the powers. We got 5, we got 0. The power on the x term goes down 1, and the power on the y term increases by 1. So the x power decreases, 5, 4, 3, 2, 1, and 0. And the y, the y term increases, goes from 0 to 1, to 2, to 3, to 4, to 5. Hey guys, the exponents, when you add them, must equal to 5. Right? 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, and so on. Okay, now, right, so this is my answer. Let me show you how I show my students how to work this. Okay? And my students actually understand this if they do it the way I'm going to show you. I use 3, guys, because if I use something more than 4, it'll probably take more than the screen here. That's why I use something like 3, something simple. Okay, here it is. I'm going to put y cubed, right? And right. So this is y cubed negative 0, because this is like my y, right? And this is my x. I mean my y and the number here. So I'm going to put y in negative 3, y in negative 3, y in negative 3, and y in negative 3, right? And then we start with 0, 3 and 0, 2 and 1, 1 and 2, and 0 and 3. Now for the combination, guys, it's going to be 3 combination 0, 3 combination 1, 3 combination 2, and 3 combination 3. Now we do simplify. So 3 combination 0 will give us 1. Negative 3 to the 0 power will give us 1. Right? And here 3 combination 1 will give us 3. Negative 3 to the first power will give us negative 3. 3 combination 2 will give us 3. Negative 3 squared will give us 9. And 3 combination 3 will give us 1. Y to the 0 will be 1. And negative 3 to the third power will give us negative 27. Now we combine them, right? 1 times y cubed will give us y cubed. 3 times negative 3 times y squared will give us negative 9y squared. 3 times 9 will give us 27y. 1 times negative 27 will give us negative 27. So this is my answer, guys. Let me go back. This is my answer right there. Okay, now let me do it again, guys. Number 17. But now I'm going to show you, okay, again, how I show my students in an easier way. Okay, solution. Right, that's my formula. So it's my first term, second term, third term, right, and fourth term, and so forth. Because here, guys, but we're looking for the fourth term, right? Out of 7. I mean, that's why you have to go all the way from n0 all the way to n7. You see, but that would take you too long. Here's where these numbers that match it, right, in red, takes priority. Okay? Again, if we notice, on the first term, it's going to be 0. This will start with 0. So it's always, for the b, the power of b is always 1 less. For the first term, right? I mean, this is my second term, it's going to be 1. For my third term, it's going to be 2. For my fourth term, it's going to be 3. So for the exponent for b, guys, it's always 1 less. Okay? So here we go, NCR. The R is always 1 less than the term. See, that's what I was trying to explain here. So, right, so we're looking for the first term. We're going to know, we know it's going to be combination 7, combination 3. Right? Because the n is always the same. Right? So if it's 7, it's going to be 7. And for the R, it's always going to be 1 less. So for the first term, it's going to be 3. Okay? 1 less than the term. Now, okay, A is 3x according to the formula, and B is 2y. We have 3x and 2y, right? That's my A, my B. So the combination will be 7 combination 3, right? And remember, this the number here always matches, the B term. You see, it's got to match. That's why it's color coded like that. So that way, it's more visual. Now, remember that the exponents, when you add them, must equal to the end, which is 7. So 3 plus one number will give us 7. So the 4 goes there. Now we simplify it. So 7 combination 3 will give us 35. 3x to the 4th power will give us 81x to the 4th. And 2y cubed will give us 8y cubed. Now we multiply them out. So this is the term that we're looking for. So 22,680 x to the 4th y cubed. Okay. Okay, now look at this one here. Okay, same similar problem. So here we go. Solution. Right, this is my formula. So we have find the S term of 6x plus 2y right to the power 9. So that's my first one, and so forth, right, like before. So here, guys, it's going to give us 9 combination 7. Right? Because the n is 9. And 1 less than the S term, will be 7. See, again, it's always 1 less. So then, right, we're going to write my A represents 6x and my B is 2y. Remember that the R here, guys, the 7 has to match, the B term. That has to be 7. Now 7 plus one number gives me 9, so it's going to be 2. Okay. Now we do 9 combination 7. It's going to give us 36. 6x squared will give us 36x squared. 2y to the 7th power will give us something like 128y to the 7th. Now we multiply them out, and we get 165,888 x squared y to the 7th. Now comes number 18. Number 18 comes from 9.6. Okay, this is counting principles. It says here, number 18. Number 18 is this comes straight from the homework. It says in a certain state, each automobile license plate number consists of 2 letters followed by 4 digits. To avoid confusion between 0 and 0, and between this is not 0, this is between O and 0, between I and 1, the letters O and I are not used. How many distinct license plate numbers are possible in this state then? Okay, so here's the solution. So there's 2 letters and 4 digits. 2 letters and 4 digits. Because remember, guys, the O and the T and the I are not used. So since there's 26 letters in the alphabet, and we exclude the O and the I, we're going to have 24. Right? So it'll be 24 times 24. And for the digits, there's no restriction, right? So 10 digits make all the numbers, right? The digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to give us 10 digits times 10 digits times 10 digits times 10 digits. We multiply them out. It's going to give us 5,760,000. That's how many different license plates are possible. Okay, now this is number 19. It says, how many different license plates are possible if each contains 3 letters followed by 3 digits? That's for part 1. For part 2, how many of these license plates contain no repeated letters and no repeated digits? Okay, so for the first part, right, notice the 26 letters are in the alphabet and 10 digits make all the numbers. Hey guys, I do this because at times when students come from another country, they don't know how many letters there are on the alphabet in the US. Right? I think Mexico has more than 26. That way they can know that it's 26 letters. So again, right, same pattern as before. Again, same pattern. So there's what, 3 letters followed by 3 digits. But here, guys, there's no restrictions, right? It doesn't say nothing about they cannot repeat, which means it's going to be 26 times 26 times 26 times 10 times 10 times 10. And here's my solution. There'll be 17,176,000 possible license plates. Okay. Now for part 2, same part as part 1, but the letters and the numbers cannot repeat. I don't know, hold on, it says here. Oh yeah, it says no repeated numbers and no repeated letters, so nothing can repeat. So those are my letters, those are my numbers. So how many letters can go in the first lot? can be all 26. Right? Now, if they cannot repeat, then it'll be times 25 times 24. Similar fashion for the digits. We start with 10 digits, and then we go to 9, and we go to 8 because they cannot repeat. We multiply it out, and we get 11,232,000 possible license plates. Okay, now this is number 20. It says find the number of a 6-member committee that can be formed from a group of people consisting of 7 women and 8 men. If the committee must have 4 women and 4 men. 4 women and 2 men. Okay? The solution is from 7 women, we're going to choose 4. Okay? From the 8 men, they need 2, but they're going to choose 2. So for the women, guys, it's going to be 7 combination 4 times 8 combination 2. 7 combination 4 will give us 35. And 8 combination 2 will give us 28. So 35 times 28 will give us 920. That's the answer, guys. That's how many possible combinations are possible. 21. It says a pair of dice are rolled. Find the probability of rolling a sum larger than 4. Okay, so solution. These are all the possible outcomes when you toss two dice. The sample space is 36. Why 36? Because there's a 6 with a 1 being first. With a 1 being second, and also in 6 with a 1 being first. So 6 times 6 is 36. Okay, now the probability is the number of the event times the number of the sample space. So it's going to give us something over 36. Okay, a probability of some being larger than 4. So it can be something more than 4. It can be 5, 6, 7, 8, 9, 10, 11, 12, right? You notice the maximum that we can reach, the sum is 12. That's why it has to go from 5 to 12. Okay, 5 will be here, guys. All these will be 5. 1, 4, 2, 3, 3, 2, and 4, 1, which is 1, 2, 3, 4. 6 is these right here, 1, 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, and 5 plus 1, and so forth. So we have 1, 2, 3, 4, 5. The sum is 7, right? In a similar fashion, we're going to count these. 1, 2, 3, 4, 5, 6. And then 8 is going to be 1, 2, 3, 4, 5. 9 is going to be 1, 2, 3, 4. 10 will be 1, 2, 3. And 11 will be 2. And 12 will only be 1. Right, so if we add them, it's going to give us 30. So the probability will be 30 over 36, which will give us 5 over 6. That's my solution. Now for B part, a sum more than 12, right? There's none because the largest sum is 6 plus 6, which will give us 12, right? It's saying that the sum larger than 12. Larger than 12 means the 12 is not included. So it's going to be 0. So 0 over 36. So the probability will be 0 because there's no way you can get a sum more than 12. Okay. I believe this is the last one here. Let me see what time is it. Oh, we still got time, about 3 minutes. It says assume that the probability of a couple having a baby boy is the same probability of having a baby girl. If the couple has 3 children, find the probability that at least 2 of them are girls. Okay. Again, with this situation, guys, it's always wise to draw a tree. Okay. A diagram tree. So here the couple having 3 children. This is for the first birth. It can be a boy or it can be a girl. Now for the second birth, if the first one's a boy, then from there it can be a boy, it can be a girl. Right now, the third term will be right. This is my first term, my first birth, second birth. Now comes the third birth. Okay, I'm sorry about that. I forgot to put the girl and the boy here at the bottom. Now here it's similar, right? This is the third birth. It can be a boy, it can be a girl. If it's a boy first and a girl, it can be a boy and a girl again. If it's a girl first and then a boy, it can be a girl, boy, and a boy. If it can be a girl and a girl, right, it can be also a girl, boy, and a girl. So these are my 3 births. So it can be BBB stands for boy, boy, girl, boy, grow, boy. Boy, grow, boy, grow, grow. Then it can be grow, boy, boy. Grow, boy, grow. Grow, grow, boy. And grow, grow, grow. Right now. This is a possible logarithmic, which is 8. Right? There's 1, 2, 3, 4, 5, 6, 7, 8. My sample space is 8. Now it means at least 2 of them are grows. What does that mean? That it can be 2 or more. It means 2 or more. So at least so the one that has 2 grows, right? 2 grows or more. So it's going to be this one here. Grow, boy. I mean, boy, grow, grow. Grow, boy, grow. Grow, grow, boy. And grow, grow, grow. All these combinations have more, at least 2 grows. How many are there? 1, 2, 3, 4. It's going to be 4 over 8, which would be 1/2. So the answer is 1/2. Okay. Hey guys, questions, guys? Okay, let me see. I believe I completed in time. It's almost 12. Well, let me go back to the host so they can tell you more about what's coming up and the upcoming events.
Thank you, Mr. Isasi, for a wonderful presentation. We do want to remind you all about our previously recorded sessions, which are available on the YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions, so please take the time to fill out the survey. Before you leave, I want to share the TVE sessions that we will have next. Next week, we'll be back with a Happy Math Hour. And next week on Math 1332, we'll be covering graph, Euler circuits, and weighted graphs. Math 2412 will be covering conics, parabolas, and ellipses. And don't forget that today at 1 p.m. we will have a student success topic, which will be Makerspace with Daniel Martinez. Thank you all for coming in today. We hope that you all have a lovely weekend. Good luck with your exam. And if you have any questions, feel free to use the chat box or mic. Have a great weekend, everyone.
Thanks, everybody. Thank you for all.
We'll see you, Mr. Isasi. Have a great weekend.
Thank you, Mr. Isasi. Take care.